Hello everybody and welcome. In today's video we're going to be finding the equations of lines given 2 points, and we're going to be going over 3 examples which are shown here on the screen. So without further ado, let's get it. Example number 1. We're given those 2 points there, and what we want to do is find the equation of the line. So what we do is basically 3 steps. Step number 1 is going to be using this equation here to find our slope. Step number 2 is we're going to be writing equation in point slope form. And then the last step is to take that equation and put it into slope intercept form. All right. So let's begin with step number 1. And what we want to do is find m, which represents our slope, and we have y2 minus y1, x2 minus x1. So the way I do it to make it easier is I'll go ahead and label my points first, and it doesn't matter the way you label it. You just have to be consistent. So this top point here, I'm going to put x1 and y1, so that represents that, and then x2 and y2. Okay, so those are my points, and now let's go ahead and plug those in to find our slope. We get m is equal to y2, which is 2, minus y1, minus y1 is negative 3. And that is all over x2, which is 7, minus, and our x1 is 2. Okay, so when we go ahead and do that, we get 2 plus 3, which is going to be 5. And then on the bottom, we'll get 7 minus 2, which is also 5. And when we reduce that, we find that our slope is equal to 1. All right, so that's step 1 complete. Now let's go on to step 2. And what we want to do is write down our point slope form. And in this case also, you can pick any of the points, but I'm going to try to keep it consistent and use the same y1 and x1 that I used before. So we get y minus y1, which is negative 3, is equal to m, which is 1, times x minus our x1, which is 2. All right, so now let's go ahead and simplify this. Y plus 3 is equal to, and what we can do on this side is distribute this 1 to everything in the parentheses. So when we do that, we'll get x minus 2. All right, and what we want to do is isolate the y here so we can get it into slope-intercept form. So to do that, we're going to go ahead and move this 3 over. And by simplifying, we get y is equal to x, negative 2 minus 3 is negative 5. All right, and this is our slope-intercept form that we wanted it in, which is the last step. Therefore, this example is complete. Example number 2. We are given these 2 points here. So before we begin, I'm just going to go ahead and label my x1, y1, x2, and y2. So I'm just going to go ahead and use the first point as my x1, and then y1, and then x2, and y2. So step number 1 is we want to find the slope. So that is m is equal to y2, which is 9, minus y1, all over x2, which is 1, minus x1, like that. And when we simplify this, we get 9 plus 3 is 12. 1 plus 3 is 4. And simplifying that further, we get m is equal to 3. So that is our slope. Now we're going to move on to step 2, and that is to write it in point slope form. And just to keep it consistent, I'm going to use my x1 and y1 that we used earlier. So we get y minus y1, which is negative 3, is equal to our slope, which is 3 times x minus our x1, which is negative 3. All right, so let's go ahead and simplify this. We'll get y plus 3 is equal to 3 times x plus 3. And from here, what I want to do is distribute this 3 over to both those in the parentheses. So we get y plus 3 is equal to 3x plus 9. And now the last step is to isolate y. So we're going to subtract 3 from both sides. And when we do that, we get y is equal to 3x plus 6. All right, so now we got our equation in slope-intercept form. Therefore, this example is complete. Example number 3. We're given these 2 points here. So I'm going to go ahead and label my values x1, y1, x2, y2. And now for step number 1, we're just going to find the slope again. So we got m is equal to y2 minus y1 all over x2 minus x1. And simplifying this, we get 12 over negative 8. And that can be reduced into 3 over 2. So that is our slope. And now we can move on to step number 2, which is to write the equation in point slope form. So that is going to be y minus our y1 is equal to our slope times x minus x1, which is 6, like that. And now I just want to simplify this a bit. So I'm going to go ahead and distribute this 3 halves into everything within the parentheses here and simplify the left-hand side as well. So y minus minus 9 is y plus 9 is equal to negative 3 halves x. And then we got minus 6 times negative 3 over 2, like that. And let's reduce a little bit or simplify a bit. So we'll get negative 3 over 2x. And when we do this here, this 2 cancels and this 6 becomes a 3. So it's negative 3 times 3. And that's going to be a positive 9. Right? I'm going to go ahead and take this over here because I'm running out of space. And we got y plus 9 is equal to negative 3 over 2x plus 9. Last thing we want to do is isolate y. So we want to subtract 9 from both sides. And then what we get here is y is equal to negative 3 halves x. Okay, and you might be wondering where the b is. Well, the b in this case is the y-intercept, and that y-intercept in this case is actually 0. And I'm going to pop open a graph on the screen here. So this graph is the graph of the equation that we just obtained. And you can see that the x and the y intercept in this case is the origin. So it's 0, 0. That's why we don't see a like a plus b on our equation just because that b is 0. So therefore, y equals negative 3 halves x is our equation, and this example is complete.